James Ward, a developer advocate at Google Cloud. This session is the Kotlin server framework Smackdown, and I picked 4 popular Kotlin server options and built the same application with all of them, and then tried to use that as a way to compare them, see how their developer experiences are different, see how their performance is different, some of those things. So let's first take a look at the application that I built. It's a very simple data-driven application, and it's just a way to store bars in a database. So what we can do is load it up, and we can come in and put in a new bar. And that's in the database, so persistent in Postgres. Okay, so that's our very simple database application. And let's take a look at some of the common code. So I wanted to be able to reuse some of the code between the different projects. And so I'll walk through that first. So first is a common module. And in the common module, what we do is we have our data class for bar, which holds a bar with a name, which is a string. So there's our basic data class. Then I also put into this project my SQL script that initializes the database, the table for bar. So that's our common project. Then I have my HTML client, which of course I wrote in Kotlin, because why not? I can write HTML in Kotlin, and I like type safety. So I have my basic web page, which loads in Bootstrap from a web jar, loads in custom CSS, loads in a JavaScript file, which we'll see in a second, and then the page layout with the form and the list of bars, that sort of thing. Okay, so that's my HTML. Nothing too exciting there. Oh, I've got my CSS here. That's pretty basic. Now for the JavaScript, this is a single page app type of thing. It's using Ajax, whatever we call it now, and making a request to the server with JSON and getting back JSON and parsing it. And so for that JavaScript client, of course, I wrote that in Kotlin as well. So you can write JavaScript in Kotlin, or something that compiles to JavaScript in Kotlin. And so what we have in here is a function refresh bars, and that just does the fetch to /bars to get JSON. And so no matter which server implementation we're doing, it's going to have the same API where we can fetch, make a request to /bars, get back the JSON. Now, one of the cool things you'll see in here is that I'm actually casting this to a bar. So that is the bar object from the common project. We can actually see in the Gradle build here where I depend on that common project. So that's how we pull that in. So that's nice that I can reuse code between the client and server. And then you'll see the DOM manipulation stuff that I'm doing in here. And then submit handler, which parses the form, turns it into the JSON, and does a post, fetch with a post to /bars. Okay, so that's my written in Kotlin JavaScript client that's shared across all the different applications. So now let's get into some of the actual server implementations. So there, as I mentioned, there's 4 different options that I picked from. And of course, there are some other options out there as well, but these are the 4 that I was most familiar with. So that's why I chose those. And so let's start actually with the Micronaut one. That's the first one that I used, and it's probably the Kotlin framework that I've had the most experience with. And let's go take a look at some of the code here. Before I do that, I want to show you some of the things that I wanted to explore when I was building these applications. One of those is using test containers. So test containers is a way to take service dependencies and make their provisioning and their lifecycle controlled by your unit tests, or also potentially by when you run your application in a development mode. And so you'll see that I have a dependency on the Postgres driver. I've got the test implementation on my test container for Postgres, and then some other database stuff in here. Micronaut you can use from Java, you can use it from Kotlin or from Groovy. And so in this case, I'm using it from Kotlin. To set up my database, what I did was in my test source directory, I created a factory bean that says, all right, we need to make sure we have a PostgreSQL connection builder and that we're in the test environment. But then what we're going to do is we're going to use test containers, and we're going to start up a test container for Postgres. And then when a bean asks for a connection to that database, we're going to connect it to that container. So the lifecycle now is managed through this bean for that test container. And then what I haven't done in these projects, but is more typical for test containers, is to also do this for the integration tests. And there's some nice support with test containers for controlling the lifecycle of the container that's running in Docker with the test containers inside of the integration tests. And so in this case, I'm providing this bean so that then in my application code, when Micronaut starts up, it says, hey, we need a suspending connection for the web application. And what happens is that Micronaut resolves the graph of beans that are available and figures out that, hey, here is the thing that is going to actually provide that Postgres connection that's also managing that Postgres test container. Okay, and then I also have one of these for production. So when I'm in production, I'm actually going to get that connection not from a test container, the connection information, but I'm going to get it from configuration or environment variables, and so this allows me to get that connection for a production application. And the other thing is that because I have the test suspending connection factory in my test scope, that means it's not actually going to end up in my production artifact. So that factory bean is not going to be there. Okay, so back to our web application. I've got a main function that starts up Micronaut, and then I've got a controller that takes my suspending connection. My GET request to /, it produces text to HTML. And then what I'm going to do is I'm going to call remember from my HTML client project, that index method that produces the index page that I wrote in Kotlin. I'm going to call .serialize on that, and that will give me back the text blob that then gets returned to the browser. So that's my GET handler for /. And then I've got my GET handler for /bars. Now, one of the nice things with Micronaut is you'll see I can use suspend funds, so that's coroutines and Kotlin, and then I'm going to call my bar DAO and do my select all and give it that connection to connect with. Okay, so that bar DAO, you may be wondering, what is that? So let's go take a look at that. What I did was I explored with all these options. I tried kind of the native kind of regular way to do database access in these different frameworks. And Micronaut has a really nice framework for doing SQL, doing database access called GORM. But one of my constraints in this project was I wanted to have this shared data class called bar. And I was just kind of being lazy. Maybe I should do a different class for my data access than the one that's getting used for kind of data transfer, value object type stuff. But I wanted to have that same class. And GORM and some of the other database frameworks that I was exploring, they needed annotations on that thing. And that got a little weird with the Kotlin multi-platform stuff that I was doing, and adding those annotations to the data classes and something that's shared. So I ended up not using GORM in this case. Also, I wasn't sure if GORM actually supported coroutines or not. So there was also a potential concern around that, but maybe it does. I don't know. So anyways, what I did was I looked around to see what are the other options that I have for database access in the Kotlin world. And there's a framework called Zico. And so I actually, for Micronaut and for Ktor, used the Zico to build my data access stuff. And so here's my bar DAO. What you do is you'll see that I create a data mapper, I give it some configuration, and then I'm also, in this case, I'm just doing raw SQL for my insert, but there is a Zico SQL library that will write the SQL for you. And so you'll see that what I'm doing is I'm creating a query from that nice DSL in Kotlin, and then I can get the SQL for that and run it. So here's my very simple data access object for my database. One of the nice things about Zico is that it supports coroutines. So you see the suspend functions there. So that's what I'm using for database access in Micronaut. I was also at the same time trying to get GraalVM to play nicely with this. And so things that do reflection don't work well or require additional configuration, may not work well with GraalVM native image stuff. And so I was also trying to limit the amount of reflection that I was doing. Also, I just don't like reflection. So, okay. So let's talk a little bit about this Micronaut application. It works. It's simple. It's annotation based. The programming model for this is very similar to Spring Boot, and was really pretty easy to figure out all the code for the Micronaut piece. I did run into some issues with Micronaut does something nice with annotations that some of the other annotation-based frameworks don't do, which is that it actually uses the annotations at compile time. So it does compile time annotation processing through something called CAPT, the Kotlin annotation processor, which is nice because then we're not doing reflection at runtime. So we avoid some of the performance overhead. We avoid some of the GraalVM potential issues there. And so I like that it does compile time access to using the annotations. But at the same time, I did run into a number of issues with something, the CAP, the Kotlin annotation processor, and Gradle. There was sometimes the Kotlin annotation processor just wouldn't run for some reason, and it took me a lot of time to debug those particular issues. And I don't know if there were Gradle issues. I don't know if there are Micronaut Gradle plugin issues or capped issues, but there were some challenges there. But nice things about Micronaut, I've written a number of production applications in Micronaut, and the programming model is nice and simple. The auto reload support is great. So when I'm writing code, I get that nice auto reload loop, and we'll see if we look over into the README for this project. We'll see, here's how you run this thing with reload, is you just do the -t, which is continuous build in Gradle, and then I created the special test run task in Gradle, and I'll show you real quick what that does. So test run, what I'm doing, really the main thing that I'm doing in test run versus just run, the normal one, is that I'm telling it to use the test runtime class path instead of the main runtime class path. And that's how I can get this test suspending connection factory into the class path when I run it with test run versus run. So of course, when back to my README here, if I am going to run this in test production mode, then I'm just going to call run, and that's going to give me my production class path. So that's a nice way to set up the difference between my test and my kind of prod run and bean configuration. So you'll see some GraalVM stuff in here. I tried really hard to get GraalVM working on this application and ran into a number of issues. Probably with some more time, I would have been able to get it working. I think generally Micronaut has pretty great GraalVM support, but there was just a couple things that I was running into around including resources that were needed and some other things that I couldn't figure out. And so I wasn't able to get this working with GraalVM after I probably spent 3 or 4 hours working on some of the GraalVM stuff for this application. But overall, I think that Micronaut has done a pretty good job with their GraalVM support. Okay, so let's see. Anything else about Micronaut? Overall, I like it. I'm impressed with Micronaut. The programming model is nice. The one kind of complaint, other than the capped issues that I ran into, was I personally don't love the annotation-based programming model. I prefer a non-annotation, more functional programming model. But for people coming from the world of Java and Spring, the annotation-based model is with Micronaut, you're going to feel very at home with that. So I think it's a great option if you're coming from that world. Okay, so that's Micronaut. Let's go on to the next one, which is Quarkus. So Quarkus is is from the folks at Red Hat. So it's based on, has some, you'll find some JBoss bits in there. You'll find some Vertex bits in there. And that was one of the things was I got a little confused by kind of some of the different options in Quarkus. I asked for some help on Twitter and found out that there was a new kind of way to do the Quarkus rest easy reactive stuff. And it wasn't quite documented yet. I'm using a brand new release for this. But overall, the Quarkus stuff is also going to feel very familiar to you if you're used to doing the annotation-based stuff. So this code is going to look very similar to what you saw with Micronaut, just different annotations. The one major difference with Quarkus is that it doesn't yet, as far as I can tell, support coroutines. So these are not coroutine-based APIs, but they do support reactive I/O, and they also support reactive I/O on the database channel. Micronaut did as well. I didn't. I don't know if I pointed that part out, but because I was using something called, let's go check and see what that thing is. So in my Gradle build, I'm using this JASync SQL in Micronaut. That's a reactive driver for Postgres. But in Quarkus, they also have a reactive driver for Postgres. And in that case, it's the Quarkus Reactive PG client is what I'm using, which is based on something from Vertex. So that's great that the database is reactive and that my controllers are also reactive. That was one of my requirements for this application, is that everything had to be reactive, but not using coroutines yet. So instead, what I do is I return, in this case, a multi-bar, which is a Java. It's not Java RX. It's something similar to Java RX called Mutiny, which I hadn't used before, but was pretty straightforward. So you can see what I can do is I can make my query, and then it's non-blocking, so I can do my non-blocking transform on it into my bar class and return that. So nice that it's non-blocking. You'll see that the add bar method also non-blocking, but returns a uni. The API for the reactive stuff was fine, but I certainly would have preferred to have coroutine support in there. So one of the things that was a little bit of a bummer in Quarkus was that there wasn't a way with their Gradle plugin, and I'm using their Gradle plugin, and it's pretty experimental, I think, at this point. And I filed a bug and they fixed it super fast, and it just hasn't gone into a release yet. But the thing that I did in the Micronaut one, and actually all the other ones, was I was able to have a class path specific to my testing stuff where I set up my test container for Postgres. And so because the Gradle plugin for Quarkus, at the point that I wrote this, doesn't support a way to do that. You'll see that my test PG pool is actually in main, not in test, where I would like it to be. But hopefully I'll be able to fix that and change that soon. But here's where I'm managing setting up the connection pool to Postgres and creating a bean factory that has that connection pool in it and starts up the test container for Postgres and all that stuff. So that was pretty straightforward. And writing the web client there was also pretty straightforward. So overall, nice experience. Quarkus also typically has really great support for GraalVM native image. And I, again, tried for a long time to get it working with this particular project and ran into a number of issues with getting it working. I think that, there's probably some libraries and stuff that I'm using that just aren't quite ready yet for what I'm doing with Quarkus and trying to do with GraalVM native image. So I wasn't able to get my static assets working correctly. I was getting an error when I was trying to construct my value object for my bar, maybe because it was in a sub project. So there were some challenges there. Oh, and one of the big challenges I actually spent quite a bit of time on was that Quarkus has a BOM, which is nice, to be able to provide versions of everything. So if we look in my build config, you'll see that I pull in that BOM on a specific version, but then I don't have to specify the versions on all these other dependencies, which is great. But I wanted to use Kotlin 1.4 instead of 1.3, which is the default. And it took me a long time to figure out how to override that version of Kotlin that was being used by the bomb. And I think ultimately what happened was when I started using the very latest 1.11 version, which just came out a couple days ago, then I think the 1.4 stuff worked a lot better. So I think that that's been resolved now, but when I was working on the previous version, had some challenges with that. Okay, so that's Quarkus. Overall, good experience. I think in general, good support for reactive and for GraalVM native image, but ran into some hurdles with that on this particular project. Okay, so that's Quarkus. Now let's talk about Spring Boot. So Spring Boot, probably the one that a lot of people are familiar with, and nice annotation-based programming like the other two that we've seen. And I was able to get reactive I/O end-to-end working, and so that was all nice. For the database access, I ended up using. Let's go. So I ended up using let's go look at the dependencies in here. I'm using the Reactor Kotlin extensions, Kotlin X Reactor extensions. So there was a few things that I had to pull in so that I could talk to, and R2DBC with Postgres, of course. So I was able to get all that stuff working together, which was nice. And you'll see that the code here is pretty nice. I get an instance of my database client, and then I run some SQL on it. I fetch that thing, and then all gives me back my flux, and then I can run a map function on my flux to convert what I get back into my bar. I'm not using any ORM stuff here, so I'm just doing manual mapping, and then doing collect list, which gives me a mono, and then a wait first, which turns that mono into a coroutine. So obviously it would be nicer to have just kind of coroutines all the way through, but the fact that I can actually use coroutines on my controller methods is certainly nice. And then the utilities to convert to coroutines from the other reactive constructs is nice as well. You'll see my add bar very similar to what you've seen in the other one. So nothing too exciting or out of the ordinary. In this case, I, like the others, created a factory that produced my bean so that I could manage the lifecycle when I'm doing testing of my test container. So that was easy and nice. One of the things that I don't love about the Spring Boot experience is that if you want to do continuous run, you need to actually run two Gradle commands. You need to do the continuous run on the classes, and then you need to do your typical boot run thing. And so I wish that would just be a single task, would make things quite a bit cleaner for me. But at least it works. The auto reload stuff works well. The thing that you'll see, which is nice, is that Spring Boot has a scope in Gradle called development only, which is where we put in our dev tools. And so that's a nice way to pull in here the development only stuff. And I think that I may be able to use that for my test container stuff that I'm doing as well. So I'll have to experiment more with that. You'll see that I do, when I run boot run, I actually override the class path to add in my test class path stuff to it so that I can get that test connection factory built into it. So I also tried to get Spring Boot working with GraalVM native image and ran into some issues with that one as well. I don't remember what all the issues were, but there was a number of things that just weren't working right. And I've tried to get Spring Boot working on some other GraalVM native image, working on some other Spring Boot projects, and run into some issues with that. And so, I haven't had a lot of success yet with Spring Boot and GraalVM native image. I know that they're working a lot on it, and that's great. Hopefully, there will continue to be great progress around that. I think some of the issues are really because I'm using Kotlin, and that's not exactly the normal with Spring Boot. There is some nicer database access stuff that I could have used in Spring Boot, of course. And in this case, I was just using this raw database client. The reason why I didn't use the nicer database access stuff was because, like some of the other data access frameworks, it actually required annotations on my data class. And as I said before, there was some issues that I had around adding those annotations to that shared data class. So I know that there are some really nice R2DBC reactive database stuff for talking to databases, but unfortunately on this project, it didn't fit my requirements to use it. But overall, Spring Boot is a great option. I've used it on a couple of production projects. When I've chosen Spring Boot, it's because the developer teams that I was working with were used to Spring Boot, and so I knew that the programming model, even though it was Kotlin, I knew that the programming model would be familiar to them. And the Spring Boot Kotlin stuff works great and supports the coroutines. So it's just an easy option when my team constraints kind of dictated that that's what I should use. Okay, so that's Spring Boot. And now let's go on to the fourth and last one, which is Ktor. So Ktor is a Kotlin specific framework for Kotlin applications. And let's go take a look at some of the code here. So Kotlin, Ktor does not have any way to do annotation-based dependency injection stuff that we've seen in the other three. And so there's some things that I like better about this approach. There's a nice DSL for configuring my server. You'll see that I'm installing some like middleware into my server. They've got WebDriver support, so I can just install that in. I can add in content negotiation with Jackson, add in routing, and now I get a nice DSL for handling my routing. Here I'm for a GET request to / I respond. That way it has support out of the box for the Kotlin X HTML stuff, which I wrote my HTML UI in. You'll see that I can nest my routes. So on a GET request to bars, I go off and get my connection and then use the DAO that we saw before, that ZealotDB one, to make my request and then respond with that. And my bars are that list of bars, which is nice. That gets automatically serialized because I installed the Jackson module and that sort of thing. And then the post method here, you'll see that I'm receiving my bar that was sent in the post, getting my connection. So one of the things you might be wondering is there's not dependency injection really. So I need this connection. So how am I actually getting that connection? So if we look at here in my application where I configure my application, you'll see that I'm including this other thing. And the other thing in the case of production, what it's doing is it's setting up a database connection based on some environment variables. And that install is then providing a way to be able to pull out that connection. And so this is kind of like dependency injection, but it's all kind of compile time validated instead of annotation reflection based. And so here's where I can actually now pull that connection out, and it may not have been set. And so that's why I am using this let and then handling that there. Okay. So one of the nice things about doing it this way is that when I'm running a production, I want to use environment variables. But when I'm running in development, I actually want to be able to use a different one. And so what I have is something similar to what you've seen before. I'm managing my test container for Postgres. And then what I'm doing is let's see, I'm starting up my server. And so this base module, and then this install connection feature, that's what's actually setting up the connection and installing it in. So, so when I run my main application, I'm actually running this test module, which is taking my base module, which we define up here. This is my base module, and adding into it something else, which is my test container with the connection pool to connect to that test container. So a bit different of a way to wire together an application, but I really do like this approach better. It's much more static and makes it, to me, much more understandable how the dependencies of an application actually get weaved together. And so, so this was this is the first time I'd written a middleware plugin for Ktor, and it turned out to be pretty simple. So, so that was nice. Okay, so then with Ktor, of course, I also tried to get it working with GraalVM, and ran into some issues with that. I was originally trying a project called JASync SQL extensions, but it used something that GraalVM couldn't figure out, and I couldn't figure out how to make it work. And so then I switched over to the Zico stuff and still couldn't get the native image stuff working. So that was a bit unfortunate that I wasn't able to get GraalVM native image working in Ktor, even with the Zico stuff. I think I ran into logback issues, and certainly Ktor doesn't provide all the nice things that the other frameworks provide around GraalVM native image, and being able to figure out what reflection gets used and figure all that stuff out, or try its best to figure that stuff out for you. Ktor doesn't give you really any support there, so it's really up to you to figure that out. And so there is a way to generate the configurations for reflection. You'll see that I generated this giant reflection configuration file, still couldn't get it working, generated some other configuration files there, and ultimately, yeah, just ran into issues and couldn't get the GraalVM native image stuff working. So, so that was a bummer. Of course, Ktor, being Kotlin friendly, supports coroutines. So what you're not actually seeing here, because I'm just in like lambdas, is that these are actually using coroutines. So when I do my select all, that's a suspend fun. And so, yeah, so it's the Ktor support of reactive is pretty nice there. And then I use the Zico database access with Ktor, and that was fine. It's a bit low level, and I ran into a few hurdles with it. Ultimately, what I kind of felt was that none of the database access options really are kind of first class Kotlin and kind of amazing yet. In the Scala world that I'm used to, there's a couple really great database access options that are very Scala first and just feel great with Scala. In the world of Kotlin, I've yet to find a database access option that actually like feels Kotlin-y to me, like that feels like it's a great option in Kotlin. And so that was one discovery from this experiment. It's just that I think data access and Kotlin server-side Kotlin server-side stuff just isn't quite there yet, at least in terms of what I would like it to be. Okay, and then one of the biggest bummers that I ran into with Ktor is that I could not get the auto reload working, the ability to do the Gradle -T and run a thing continuously. It's supposed to work. I could not get it working. I filed a bug and haven't heard back on that one yet. So, so yeah, overall, I like Ktor. It feels good from a Kotlin user perspective, but I think it still has some rough edges that make it so. I haven't put it into production on anything yet, but I'm sure I will at some point as some of those rough edges get handled. Okay, so now let's get on to performance. So that's always something that people very curious about. How does performance differ between these things? And so I created a way to test the performance of those 4 different applications. What I do is I have a Gradle subproject here, which does the Docker build for each of those 4 server projects. And then I can run a performance test on the Docker containers for those. So let's go look at the performance test here for, let's just look at the Ktor one. So the nice thing about being able to create the Docker containers for these server things is that I can deploy them anywhere containers work, Kubernetes, Cloud Run, wherever. But then I can also use those containers from test containers to run performance tests and I could run integration tests, that kind of thing. And so what we're seeing in this, this is using Gatling. And in Gatling, what I'm doing is I'm starting up my Postgres test container. Then I'm starting up my Ktor container, telling it to use the Ktor server Docker container, which I created as part of the build for this thing. And then I wait for /bars to be available, give it the connection information for how to connect to Postgres, start up the thing, and then I create my test. And in my test scenario, what I'm doing is I am making 10 requests to /bars. So just boom, 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 hit that /bars, get that result as JSON. And then I make 1 request to add a bar and give it the JSON for a bar to add. So very, very basic scenario. And I'm going to do this with 1,000 concurrent users. So that's going to end up being 10,000 GET requests and 1,000 add requests. One of the interesting things that this is showing is that the data payload for the get to /bars grows as we add more bars. So it's interesting to see how that impacts performance. Okay, so I'm able to run my scenario and I run it for all 4, and you can do all this, run it all on your own as well. But let's hop over to the browser to check out some of the results here. Okay, so for Ktor, here we see my number of requests. Sure enough, I got 10,000 OK responses. That's good. My 99th percentile response time was not that great. 3.7 seconds there for that. So at some point, something got a little slow. We can go look at the graphs and see. Looks like most of our requests were pretty fast, but then some of them got kind of hung up. Maybe I didn't have enough threads allocated, or a lot of times with reactive. Hopefully, you don't have to worry too much about some of that if you're reactive all the way down. But looks like there was some things that got kind of hung up there. So you can dig into the details for that. That's all up on my GitHub, or you can go run them on your own. Okay, so that's Ktor. Overall, like pretty good performance with 1,000 concurrent users. Okay, now let's check out here. This is Micronaut. Micronaut also 10,000 OK responses. That's good. 99th percentile was just under 2 seconds, so a bit better than Ktor. But really, kind of what I'm looking for is I don't want to see errors happening. You'll see that there's pretty big distribution of response times, and you can go check out the details of that. But overall, I think that this is performing great. Okay, then Quarkus. Quarkus, you'll see 10,000 OK responses. That's good. 99th percentile, 2.5 seconds. So pretty similar to Ktor. Actually, no, faster than Ktor. Ktor was so far the slowest at 3.7 seconds. Micronaut, nice and fast, just under 2 seconds for 99th percentile. And then a little bit slower with Quarkus at 2.5 seconds. So, so overall, I think Quarkus is performing well. One thing to note is that with Quarkus, I was using the kind of old reactive stack of things up until like a day ago, when somebody helped me out on Twitter to switch over to the new one. And the old one, I was actually getting like 60-70% failure rate with this same test. And so there was something wrong in the reactive stack there. But luckily the new reactive stuff that they have fixed that. So that was good. Okay, and then finally, let's check out the Spring Boot one. Spring Boot, 99th percentile, just about the same as Micronaut. So nice and fast, no errors. You can check out the distribution of responses. And so also nice, solid results there. So overall, I think this is good. I think really performance-wise, all of these are pretty acceptable. Not sure why Ktor was almost 2 times slower than the others, but I think it was usable and no errors, which was good for this test. Of course, if you want to go, tweak these parameters, make do different scenario, increase the number of users, do the ramp up, so you can go in and edit that and run those tests. Everything that I've shown here is all up on my GitHub. GitHub.com, James Ward, Kotlin Server Framework Smackdown, and you should be able to run all this. All the instructions that are in here for how to run it with test containers. You just need Docker to be able to run this stuff, and you will see the performance test to run those. There's the Gradle command to do that. So overall, as a summary, I think if you're used to if you and your team are used to annotation-based stuff, then really any of the options between Micronaut, Quarkus, and Spring Boot are good options. One thing I do like about Micronaut is that they have put some work into a good Android support. So I've actually used Micronaut's HTTP client in an Android app, and that was nice to be able to do that. Ktor takes that a bit further, and they support Kotlin multi-platform for their HTTP client. So that means that in my JS client, I could actually use the Ktor client instead of the browser fetch API that I'm currently using. And so that's a nice thing that Ktor is kind of experimenting with, is can we actually make this a multi-platform Kotlin project, and what does that mean? What does that look like? How does that affect how we design our APIs and that sort of thing? And so I do like that Ktor is focusing on multi-platform. That was one of my focuses here, was to be able to share code across multiple. Maybe I should in the future add in an Android client to this. That would make it even more fun. Maybe an iOS client, something like that, native client. But I think Ktor is going to shine on that front with the multi-platform support. So in terms of GraalVM, I think that today Micronaut and Quarkus, if you're doing GraalVM native image, I think that Micronaut and Quarkus are generally going to be a lot better, just because they've got great tooling support to help create your configuration that's needed for GraalVM native image. So would lean that direction. I know Spring Boot is working on it and it's coming along, but just I haven't had personal success with it yet. And then database access, I think, is going to be one of the hardest things here. I just don't love any of the Kotlin database access stuff that's out there today. So hopefully that space continues to evolve, and we get some more Kotlin kind of language idiomatic database access things out there. So yeah, check out the source code and ping me with any questions that you have. Would love any improvements that people have to this. As I said, I've done a number of production Micronaut applications. I think I've done 1 or 2 Spring Boot Kotlin. This is all Kotlin. And 1 or 2 Spring Boot ones. I haven't done any Quarkus ones, and I haven't done any Ktor ones yet. So we'll also let you all know as I do more production stuff how it goes with some of those other frameworks. So yeah, and check me out on Twitter _James Ward, and thanks for listening.